Hello students, good evening.
Good evening, ma'am.
Myself Shubhi Bansal. I am a PhD scholar as well as a PMRF scholar from the Department of Computer Science and Engineering IIT Indore. Today we will be having a live session according to the concepts discussed in week 5 lecture video series that primarily talked about syntactical parsing, introduction to context-free grammars, probabilistic CFG, and CKY, right? I hope all of you have gone through the videos. Have all of you gone through the videos of this week? Okay, good. So, also, did you try to attempt the numericals that were there in the assignment? Because today I'll be covering some of the concepts. Like I'll be covering the same topic. First, I'll like briefly give you an idea what the concept is. Then we'll solve one question using CFG as well as the probabilistic CFG. Some questions related to how to convert CFG to CNF normal form for the CKY parser. And yet another aspect that we would cover today is from the coding perspective, how to do these. So let us wait for 2 to 3 minutes so that others can join and we begin the discussion soon. So, yeah, let's wait. So I hope all of you have gone through the videos. So can you tell me like what is context-free grammar? What is CFG, context-free grammar? Anybody? Please interact as much as possible. It will help us to create a good environment.
There is no influence of the words which are occurring prior and after to the current word.
Sorry, is there any connectivity issue from my side, you mean to say?
No, it's fine. I'm able to hear you.
Okay, so could you please repeat your question?
It's not a question. I was trying to answer it. Context-free grammar is considering a current word. There is no influence of the words which are occurring prior and after the word.
Okay, could you tell me in terms of what is the grammar, what are the rules, and like in which stage of parsing it is used, like that from that perspective, I wanted to know. Like LHS and RHS, you know what a terminal, non-terminal is, what grammar is. All of you are clear with what grammar is, why we need CFG? Or should I
Yeah,
take up first a little discussion on that? Would you want me to take some discussion on that? Okay, could you please raise your hands who all want me to discuss a little about the CFGs first so that I can proceed accordingly? I'll have a rough idea. Looking forward. Please go ahead. Okay. Okay, sure. Then we'll discuss the concept a little bit and then we proceed to solving the numericals as well as how we can do these like the parsing, syntactical parsing using the Python codes. I hope that will be okay. So these will be the contents we'll be covering today. So I'll begin with what CFG is. at any point there is any connectivity issue or anything, please let me know. So today we'll be covering week 5, and we'll be covering what CFG is. So why convert to CNF, how to convert. Then in CFG we will also cover the two types of parsing that are there. Can anybody tell what are the two types of the parsers in CFG? Like there are two designs, how I can derive the sentence.
Top down and bottom up parcel.
Very good. Top down and bottom up parsing. That also we will cover a bit, some examples, and then we will have a look at the CFG, how to solve some numericals, and then probabilistic CFG. And then we will cover all of this from the coding perspective if the time allows. So this is mostly needed for what is the algorithm, CYK or CKY? I think CKY, right?
CNF and CKY.
Sorry,
CYK.
this is right, है ना? CKY. Okay. So, okay, let's begin. So, as some of you wanted to have a little discussion on the concept, so just a second, let me. So, my screen is visible to all of you, right?
Ma'am, your screen is not shared, ma'am.
My screen is not shared. Okay, yeah. Okay, thanks for letting me know. Let me share my screen. So, I was writing these concepts that we will be covering today. So, I hope all of you are clear with this. Now, let us have a brief look at what CFG is. So, CFG stands for the context free grammar. And context free grammar. So, what is NLP? Can anybody tell me what is the like to you in general? You have covered almost a month has passed since we have been doing this course. So, can anybody tell me what NLP is? Like in brief, like in general, what do you think NLP is? What have you understood so
Processing
far?
the text data.
Processing the text data, or anyone else? So, can I say it is the ability of the computer to understand the human language?
Yes.
It is the ability of the computer software to understand human language, or you could say the natural language. Humans can communicate in a variety of ways that won't be just limited to text, because we see we also share the data in the form of videos, right? Photographs, right? Memes, audio clips. So memes is nothing but the combination of video and text, right? Audio, it constitutes the videos, right? Or it could be just the audio clips as well. So as we know that it is the ability of the computer softwares to understand and then process the human language. So there can be multiple type of languages if we come to text. Then each language will have its own structure. Own structure means own structure means what is the hierarchy, what are the rules. Rules means in terms of subject should come first, object and then verb, or subject verb and object. So this set of rules, so this is the set of the rules which we do not know what a particular language follows. Maybe English follows this or this, but on the other hand, there are a variety of other Indic languages that may not follow the same order as subject, object, verb as the same as the English language, right? So how will you determine this rule? So how will you determine what is the set? Like say there is an example. I eat a mango. So could you tell me what is the order here? The subject is coming first, then the verb, then the object, or subject, object, verb? Out of the first and second, what do you think English language follows according to this sentence?
Subject, verb, object.
Yes, it is subject, verb, and object. This is subject, this is the verb I eat, and this is the object that we are eating, mango. Okay, so English is following this subject, verb, object. But say I write the same sentence in Hindi. Pardon for those who cannot like have a little difficulty. Please be there for a moment. So what I will say in Hindi, मैं आम खा रही हूँ, right? So what order is it following? मैं means your subject, am is the object, right? And खा रही हूँ is your verb. So we see that in Hindi we are following a different rule, that is SOV, right? But in English what we are following is the subject verb object. Now who will determine this? So we are everybody there with me so far?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay, great. So, just a second. I think I need to insert some slides in here. Just a second. Okay. So, coming back to our discussion, we were seeing that different languages are following different order, right? English is following the subject verb object order, but on the other hand, some Indic languages like Hindi, as we saw with this particular example, it is following the subject object verb order. So who is going to determine this? It will be determined by the grammar. Okay, what is the grammar? It is a set of the rules that determine how the language is structured, how the sentences in that language are structured, right? So also it means what is allowed, what is not allowed, what is allowable, what is not allowable. That all we will cover with the help of the grammar. So in grammar, what do we have? A start symbol, a non-terminal, a terminal, and some protection rules. This is clear to all, I hope. If you have watched the lecture, this will be clear to all. However, I am also trying to cover, so please listen very carefully. So S here stands for the start symbol. V is the non-terminal. So what is non-terminal? Can anybody tell what is non-terminal? So we can say,
Lowercase letter.
yes. So I am saying grammar is how many tuple set? We call this as a tuple. So we have, so in the grammar, we have start symbol, non-terminal, terminal, and some production rules,
Production tools.
right? So S start stands for the start symbol, V is for the non-terminal. So I was asking you, does anyone of you know, do anyone of you know what a non-terminal is? What is the difference between a non-terminal and a terminal?
Non-terminal can be derived the terminal one. Terminal is the leaf node, which will be the last.
Very good. Yes, very correct. So, terminal can be directly the words from your vocabulary, right? But the non-terminal can help you to derive the terminals further or some non-terminals as well. Okay? But this cannot derive anything further. This cannot derive anything further. This can derive things further. Okay? So we'll see with some examples what I am trying to say. So, and this all comes under the concept of parsing. This all comes under the concept of parsing. Okay. So what is parsing? So you have some NLP software, say your computer program, that will try to understand the human language. How it will try to understand? It will have some grammar, That is some set of rules. In that grammar, you have two sides, LHS and RHS. So what always will be there on the LHS and RHS? LHS stands for left hand side and RHS is the right hand side. So can anybody tell me, like, so before coming to LHS and RHS, what is parsing? What is parsing according to you?
To determine the structure of the sentence.
Yes. So taking the meaning out of the input sentence, right? Taking the meaning from input sentences. So in LHS, what all we can have? Can we have a non-terminal in the LHS? Left hand side?
Yes, only non-terminal. And for the right-hand side, we can have terminal and the non-terminal.
Yes, yes. Correct, very correct. On the LHS, you can have the non-terminal, but on the RHS, you can have non-terminal as well as the terminal. And this start symbol, is it a terminal or a non-terminal?
Non-terminal.
Terminal. And on the LHS, can you have more than one symbol or only a single symbol?
Single.
Single
Only
symbol
single.
will be there. But on the RHS, you can have more than one symbol, right? Is it correct? And that symbol
Yes, ma'am.
could be terminal or a non-terminal, correct? So for example, just help me to derive how will you draw the parse tree for this? Just a second. So given this sentence, how will you draw the parse tree? And the production rules have already been given to you. As I said, we will be covering some numericals. So John hit the ball. All of you should draw the parse tree for this. So the production rules, as I said, the grammar is a four tuple set, right? And there will be some production rules. So the production rules go like this. Start symbol will help you to derive a noun and a verb phrase. Word phrase will help you derive verb and a noun phrase. Noun phrase can derive noun. Noun phrase can also derive the determiner as well as the noun. So just a second. Okay, so first example we will do together and then we will see how to go ahead. So this is in general we are talking about the grammars. We've not come to the CFG part yet. So so if we know what is John, it is a noun, right? It is a word. The is determiner. And ball, what is ball? Is it a noun here? All of you
Yes.
agree that it is a noun here?
Yes.
Okay, so now let us derive this sentence. So I'll start with the start symbol. We are taking the top down approach. Okay, so I'm starting with the start symbol and I want to derive this sentence. John hit the ball. So I have only, see, here we are following those rules that I just discussed. What were the rules? On the LHS, you'll always have the start symbol and a single symbol is there. That is always the non-terminal. But on the RHS, what we wrote, we can have the non-terminal or the terminal. Here we are having the non-terminals as well as the terminals. Terminals are what? Your determiners. And these vocabulary words. We'll see how. And you can also see that you are having more than one symbol on the RHS, right? Is it clear to all? Is it clear?
Yes, yes.
Okay.
Yes, ma'am. Yes.
So let us now start deriving. Write the production rule for S. S goes to N and VP, right? And then using this noun, which production rule I should use? So this can be noun or noun phrase. Don't confuse it, okay? So N and VP. So now say John is the noun, we can directly derive it. But now I want to derive the remaining three words also. So verb phrase. We come to the verb phrase. What are the two rules for the verb phrase? It is a verb as well as the noun phrase. See, next I want is a verb only, right? John hit. So should I take this rule or this? Should I take this rule? It is correct only, right? And there is only one rule for this. But if I just take here for the noun phrase, if you take the noun, okay, let us stick with this. Noun and the verb phrase, you got the verb and you got the noun phrase. So from here, John, you can get, noun you can get the John, and from verb you will get hit. Now for the noun phrase, what you want is next is the and then ball. So what is the is it is a determiner, and you have here two possibilities for the noun phrase, right? It can be a noun. If it is directly noun, I cannot get the word the. Is it clear to all? But what I want is the. So I will not go with this rule, I'll go with this. Is it clear why we went with the second rule of NP and not the first? Any doubt to anyone?
No, ma'am.
Okay, so from the determiner we can get the, and from the noun we can get ball. So this is what now we derive is called as a parse tree. And a grammar that can have more than one parse tree is said to be ambiguous, right? So every grammar should have only one parse tree. Only then it is said to be what? If a grammar has more than one parse tree, it is ambiguous. But if it has only one parse tree, then what is it?
Unambiguous.
Unambiguous. Now coming to the CFG part. So as we all know, CFG stands for the context-free grammar. There are two other names for it. Can anybody tell? Can anybody tell what are the two other names for it? So this is also called as the phrase structure grammar. As we saw in the previous set of the production rules, we were deriving verb phrases or noun phrases, right? And these help you to determine the structure of your sentence. So this is also called as the phrase structure grammar. Yet another name for it, based on the scientists who found it, is the Backus-Nance form, BNF. Sometimes this question can be asked, so maybe it's good if you remember. So CFG, it is a formal grammar. It is a formal grammar which is used to generate all the possible string in a given language, which is used to generate all possible strings in a given language. We'll come to the numericals part also, but as some of you had wanted me to discuss this, so I'm covering this aspect. And in the CFG, we can write the rules in this format. Alpha goes to beta, where alpha can only go to the non-terminal, but beta, that is your LHS, it can be the terminal as well as the non-terminal, right? Any combination. Is it clear? What are the rules for CFG? Any doubt to anyone? Just in case you have not covered or you have not understood, please ask again. Is it clear what are the rules for CFG?
Yes, ma'am.
Okay. Now let us then go to one example. So, okay. So I'll give you some production rules and a sentence, and this time you all will draw the parse tree, okay? So the sentence is, the man read this book, okay? And the rules are production rules. That is your P. What are those rules? Is S derives NP, PP. S derives auxiliary NP VP. S can also derive VP. NP will derive determiner and the noun. VP can give you verb as well as VP can give you the verb as well as the noun phrase. And in this particular context, the determiner will be this, that, the. Noun will be book, flight, John, ball, meal. Verb will be book, include, read, and auxiliary verb will be does and is. So can all of you please go ahead and derive this? Can you draw a parse tree for this using the given production rules? I urge all of you to solve it. Okay, correct. Translation of expression. Understanding. Menu screen is mentioned. Okay, good. So please all of you derive this. Draw the parse tree. Then I'll also draw after like 2 minutes. Please raise your hands when you have solved so that I can know. Okay. Two of you have done. Please all of you try. Please try. The rules are given on the left hand side and what these terminals and non-terminals help us to derive, that is given on the right hand side of my screen. Take 1 more minute. I want to see more hands raised. Okay. Go ahead, everyone. Please try. This is easy. We'll also be covering how to convert CFG to CNF, then the probabilistic CFGs today. So it's very important that you understand this thoroughly. I think lots of you, many people have solved. Let us see. One, two, three, four. Others? Okay. Okay, then let's go ahead and discuss. So what should be the first rule? We'll start with the start symbol, that is clear. But even for the start symbol, we are having three rules here, right? So first one is, so anybody needs more time or should I begin solving this? Please let me know if you need more time. I can wait. Shall I go ahead and solve then? Since there is no response. Anybody needs more time to solve? Okay. Assuming that you all of you have solved, let us discuss it once. So first I want is the man read this book. let us first understand what do we understand out of this. So the will be a determiner, right? Man is what here? A noun. What is read? Verb. This is what? This will be which part of speech? As of here, again a determiner because I can see. And the book acts as a verb here or as a noun, because we can see book has been given in both the
Noun.
cases. Okay, so it is noun, as somebody rightly said. So this we have to understand on our own in a particular sense how a word is being used. Okay, so now let us go ahead and derive the parse tree. So I'll start with the start symbol. So beginning with the start symbol. So what should I choose? First of all, what I want is a determiner. So what all will help me to derive a determiner would be a noun phrase, right? If I choose auxiliary, then I can't be able to come I can't be able to derive the. So this rule not applicable in the first go. Again, it is a verb phrase. Another rule says a verb phrase. This is also not applicable. So I go ahead with this in the first go. So I will write what? NP and VP. Okay. Let me go to the next slide and write. S will go to NP and VP. Right. So NP will help me now. What is the next word that is coming? The man. So in NP, what we want is a determiner. And we can see for NP, there is only one rule. So we can go ahead and write determiner and a noun, right? And from the determiner, I can get the. And from the noun, for is there any another, you know, any production rule for noun? There is no other production rule. So we see from noun, can we get man? The man. Man is not given. Actually, man should have been given here in the noun. I think I missed it. So we can directly get from here man. Now coming to the verb phrase, what we need is read, right? Read. So always keep in mind what you need next. But just having the VP goes to verb will not help me to derive the entire sentence. It will stop right away here. So I'll go ahead with the second rule of verb phrase as of now. So what is that second rule states? Verb and a noun phrase. Verb and a noun phrase. And verb will help me to derive what? Read, because I can see it is given in the set of the production rules. So I derive my sentence until here now. The man read. Now I want next is noun phrase should help me derive the determiner and the noun. Is there any such rule? Yes, here. So it will help me to go determiner and the noun. Determiner will then go to this, right? The man read this. And again, we can see in noun, book has already been given to us. And we know that the word book is being used here as a verb. So I hope all of you got this parse tree. Is it is it clear?
Yes.
Yes, ma'am.
Yes.
Yes. Clear,
Okay,
ma'am.
great, great. So now there are two methods of CFG parsing. That is, first is top down. Second one is bottom up. Bottom up. Right? So say I'll give you one example. Again, you try to solve book that flight. And the production rules that are given to us go like this. The production rules go like this. S will help you derive noun phrase and the verb phrase. Start symbol. Noun phrase will help you derive article, or it can be a determiner. Okay? And a noun. Noun phrase again will help you derive article or a determiner. If it is written ART, assume it's article only. And then adjective and the noun. Verb phrase will help you derive the verb. Verb phrase will also help you derive the verb and the noun phrase. Now all of you draw a parse tree for this using the first approach, bottom up. Oh sorry, top down. Then we will solve this again using bottom up also. Okay? Please try. All of you should try. And please raise your hands when you are done. So please choose very carefully at what point of time which rule of NP I have to pick and which rule of VP I have to pick, because there are two rules for each of them. Just a second. I think I should modify the rule here as should help you derive the VP and the NP. Right? Please try now. Please try now. Please judge very carefully whether the word book here is now being used as a noun or a verb. That understanding alters all of your sentence structure. And that you have to decide on your own, given the context of the sentence. How is it being used? Whether the word book is being used here as a verb or as a noun. Context is what the surrounding words are saying about a particular word, right? How my surroundings are determining the part of the speech for this particular word that I'm currently at. So please raise your hands when you have solved it using when you have drawn the parse tree using the top-down parsing approach. Please raise your hands. Okay. 4 people have done. 1 more minute you take. All of you, I want to see more responses, more hands raised. Please try. Okay, let us solve now. It's easy only. Okay. So, a different colored pen. So I know the word book, how is it being used here? Can anybody tell? Unmute and tell.
Verb.
Verb. And that is used as a determiner, right? And flight is what? Is it a verb or a noun?
No.
It is
Noun. Noun.
correct. So now let us see how to do. Let us start with the start symbol since it is the top-down approach. In the top-down approach, we begin from the start symbol and then we go to the leaf notes, right? So simply top-down fashion, you start with the start symbol and then you go to the leaf notes. Leaf notes means your words that appear in your target sentence. So we have only one rule here, VP, NP, right? And now VP will help me to derive, should I go ahead with the verb or the verb now? Verb and the verb noun. Which rule out of these two I should prefer?
2.
Are you sure?
EP.
Sorry, it's 1.
It should be one. Why? Because if you take we, NP, NP, but we don't need two nouns here, right? Is it okay? Is it okay? And then for the,
Yes.
okay, great. Then for the noun phrase, what rule I should take? Whether I should take again the first rule or the second rule. Let us say with the first rule, it should be the determiner and the noun. So I am saying this can act as a determiner because in the previous slide we saw that determiner will come under the category of that only, right? So if nothing specific has been given, definitely that will not be an adjective, right? So just take it as a determiner. Neither it will be a verb or a noun phrase. So taking it as a determiner, we go ahead with this rule. So now article and noun, determiner and noun is present in both. But here you have an adjective also. So do I need an adjective in my target sentence?
No.
So we go ahead with the first rule and not the second one. This is how you will determine. So determiner and the noun. So book will come out of the verb. From you can get that, and from noun you can get flight. Just in case in some sentence this part is not given to you, you will do this manner, like understand which word will map to what. Now solve the same using the top bottom up approach. Book, that, flight. And the rules, set of the rules remains the same. Let me write here again. VP, NP, and NP goes to article or determiner and the noun. NP also goes to article, adjective, and the noun. This is your determiner. VP goes to V and VP goes to NP. VP goes to V and VP goes to N. What? VNP. VNP. So this is first, second, third, fourth, and fifth. So let me give you a hint. In the bottom up approach, what you will do? In the bottom up approach, first of all, you will write the leaf notes and then you move towards the start symbol. As the name says, bottom up parsing, you move from the leaf notes to the start symbol. Okay? Please try now. Now we know that book stands here for the verb, that stands for the determiner, and flight stands for the noun, which all of them will help me to come at the start symbol. Choose that set of rules accordingly. I'm doing with the same example so that we can have a clear understanding how these two approaches are different from each other. In the exam, there can be two different questions, like two different sentences with two different approaches, or in the same manner. Same question, but it can be asked you to solve using either the top down or the bottom up approach. So, all of you, please try. Okay, good. Premlata already solved. I want to see more hands raised. Please try. Okay, good. Seems quite some people have solved it already. So let us see how it will be. So we know that first of all, you can write that part of speech here itself. Verb, determiner, and the noun. This will help you to analyze which set of rules to take now. So if I take, say, the fourth rule, so what I will get? VP. But if I take, now I see that if I take the fifth rule, V and NP. So if I take the fifth rule, it will not work, right? Why? Because it needs a noun phrase, but we are not having a noun phrase adjacent to it. That's why I picked this rule first. Clear to all? Why we didn't go with the fifth rule and why we went with the fourth rule?
Hmm.
Okay. Please let me know if you are understanding so that I can know how many people are able to understand or we need to discuss it again. So moving ahead, then we see we have the combination of determiner and the noun. So if we see, now we have to focus on the RHS. Why? Because we want to go to the LHS, right? The start symbol. So you can assume in the bottom up approach, you want to take this approach, but in the top down, you take this approach, left to right. Okay. So this can be like one little hint for you to solve easily. Now we see in the RHS, we have the combination of article and a noun, that is determiner and the noun, and that goes to NP. But if I have the combination of article, adjective and noun, only then I can use rule 3. Since I have no such combination, I'll prefer to go with the rule 2, and what I get is NP. And now I see whether VP and NP as a combination appear in the RHS. So yes, they do appear in rule 1 and that helps me to derive the start symbol. So is it clear to all now how we did the same example using the bottom up parser? Is it clear to all?
Yes, ma'am.
Clear, ma'am.
Okay, great. Now let us go ahead and solve for yet another example. This we have done, and also we have covered. Now please solve this, but I need to check the set of the rules for this. Just a second. Just a second. VP goes to V and NP. NP goes to okay, please solve this example now. Simple, normal sentence. Peter prefers the flight from Denver. And the production rules that are given to you goes like this. S goes to NP, VP. NP goes to, and NP goes to Peter also. NP goes to N. Also NP goes to determiner and the noun. NP also goes to NP and PP. So you have to determine carefully what you want to choose. Verb goes to verb. So verb phrase goes to verb and verb is prefer. and PP goes to P and NP. And NP goes to noun. So NP, N can be Peter or Denver. P can be from. NP is Denver, right? Determiner is the. Again, noun can also be flight. Peter prefers the flight from Denver. Yes, please solve. Please draw the parse tree. Normal parse tree using the top-down parser. Please draw, all of you. Give it a try once. NP goes to NP, PP. NP goes to determiner and the noun. And then PP goes to P and NP. Determiner is the, noun is flight, Denver, Peter. Verb is prefer. Yeah, correct. Please solve. Everything is correct in this question. So then after that we will solve one with using CFG and the probabilistic CFG. What is the need for CKY? How to convert CFG to CNF? Because that is
V-
needed for the CKY parser. We'll have a look in few minutes.
VP production has only one rule. Huh?
Yes, VP production has only one rule here, V. No other rule is there. So here the intelligence lies in choosing how to choose NP rule. That is the only thing you need to determine. Done?
I'm stuck. First step.
Okay. Take your time. The sentence grows bigger, so it becomes little difficult to tackle. So at every point of time, please choose the step very carefully. Which rule to take. And if it is wrong, then cut it and go over it again. But before all of that, it's very important to determine what according to you is the part of the speech for a given word here. Like here the word flight, whether it stands for whether it appears as a verb or as a noun, that you have to decide first. Because if that is wrong, then your entire parsing rules, how you are choosing, how you're creating the parse tree will also may appear wrong at the first step. It may appear right to you, but it may not actually be right.
Yeah, even SC is also given only rule, right? NPVP, there is no other
Yes, yes.
possibility.
Only one rule. For here, only NP you have to choose carefully. Try for one more minute. When we see, I'll definitely solve it. Just give it a minute.
PP is preposition, is it?
Yes, yes. And then it helps you to derive a preposition and a noun phrase. Prepositional phrase. PP. So let me see how many of you are able to solve. Who's having the doubt? Somebody said I'm having a doubt, not able to solve. Okay. Two people have solved already. Others, please try. you able to solve now?
No.
Okay. Let us see how to do it. No issues. If still you have a doubt, then let me know. We will discuss further. Okay. So since we are having only one rule here, I'll solve in the middle part. So let me know if it is okay for you. So, okay. First of all, let us determine this. Peter here stands for the noun, right? Prefers is a verb. The is a determiner. What is flight here? Noun or a verb?
Noun.
Noun.
From is a preposition. P. Denver is again a noun, right?
Noun.
Yes, great. Now let us solve it. S. It helps you to derive 2 NP VP. Now first what I want is Peter, but that is not the only thing I want. So I can either go with this rule or this rule, right? Now immediately after a noun. So NP, see here. For NP there are three rules that are written. NP goes to N, NP goes to what? NP and PP. NP goes to determiner and noun. So see here, if I choose NP goes to determiner and noun, NP goes to noun, NP goes to NPPP. Let us write all the possibilities and explore. So what I want first of all here is Peter. So definitely I want a noun, right? That I can get if I choose NP as a noun or NP as a noun phrase, these two. I do not want a determiner in the beginning, so this is ruled out, right? Correct? Is it clear till this point?
Yes.
Okay. Now NP again comes. So for NP, I can again use this set of the rules. I can just stop here. So let us not stop here. Let's say this helps you to derive Peter. But we need more words from here. Peter prefers. I need what? A now, what? A verb phrase, right? Immediately that should follow. So if I again go for NP, NP will help you to derive what? Either a noun phrase or a verb phrase. I can see I will never get a verb in this scenario, right? No production of NP or PP. Even if PP comes, it will help me to derive only the preposition and the noun phrase only. Verb will not come, right? Is it
Yes.
clear? So what I will prefer to go ahead with this. So what I will prefer to go ahead is this. Clear till this point?
Yeah.
NP goes to N and N gives you Peter. Now come here. Verb phrase. Now there is only one production. Okay, I think the production rules are wrong or what?
I think one more verb related should be there.
Yes, you are right.
Verb cannot be taken further. Yeah.
Yes, Peter prefers the flight and VP should give you VP and NP. That should do, right? So if we take VP as a verb and NP then will be the determiner and the noun. Yes, you are right. The rule was incomplete. Pardon. So shall I
And
stop?
will there be any questions or validation for given a sentence or language? We need to develop a grammar
No, no,
or
no, not
rule.
like that.
Okay.
That's
You are
that's what
deriving
I
on your
said.
own.
Sorry.
You are deriving these grammars on your own for the
Yeah.
sentence.
Like I was just trying to give some questions on the go so that I am
Okay.
able to understand that you understood the concepts correctly or not. Okay.
Okay. Thank you.
Yeah. Okay. So now if we see for VP, we have two more productions here. VP can give you VP NP and VP can give you verb. So since we only not want only just a single verb, we prefer to go ahead with this. So VP gives you VP and NP. And yeah, that was a mistake from my side only. VP gives you V and V will give you prefers, right? Now from the noun phrase, you have done till here. Now you want to do from the flight. Simply we can see The is a determiner, and then this rule can work. Determiner and the noun phrase, right? It's just not a noun, it's a noun phrase. It's a noun phrase. So the noun, again noun phrase. What I can do, what I need is a noun and then a preposition, right? So what I'll go ahead with, some rule of noun phrase that helps me to derive the noun first and then a prepositional phrase. So what I can do is NP goes to NPPP. NP can also, I can take the production that amounts to N, that is flight, right? And from PP I will get PNP, refer to the rule here, PNP. From P I can get from, here, and NP, again N, and then this will be Denver. Is it clear? Is it clear now?
Yes. Yeah.
Okay. Anybody, any doubt in this question? Please let me know. Please unmute and ask if there is any doubt. So assuming that
Clear, ma'am. Everything is clear.
super. So now let us move to the CKY parser. That is like little more, I would think it is little important to understand it correctly. So please pay attention, and if you have at any point any doubt, let me know. So let us do the CKY parser. One and two numericals related to it. How to convert CFG to CNF and why, and then the probabilistic CFG. So CKY parser. This is by the name of some scientist. You can refer. So sentence is there. You perform some parsing on it, right? And from parsing, what we get, what we were drawing so far is the parse tree, or there is another name for it, syntax tree, right? Syntax is what is the structure, right? Parsing is nothing but the set of the rules according to which you are deriving that structure. So now for the CKY, you cannot just directly pass the CFG. Why we cannot pass? Because there are a few shortcomings in the CFG, and you need to first convert CFG to CNF. Only then you can pass it as the input to the CKY parser. Okay? Directly CFG it will not be able to process. Why? Now let us see why we need to convert CFG to CNF so that it can be parsed by the CKY parser. Why? Why can CFG not be directly passed to CKY? Let us see. There are a few challenges in the parsing. So first challenge can be ambiguity. You can have more than one parse tree for a given grammar, right? Another can be, there can be recursion. That is, the solution of intermediate steps is not being stored somewhere. Intermediate subproblems is not being stored somewhere. Third could be related to this only. Repeated substructures are there, and then you are solving them again and again. Had you stored the result of the intermediate subproblem, you would not have needed to do the computation again and again. And this results in huge space and time complexity. These are some of the challenges in the parsing. Okay. So, then to this rescue comes the CKY parser. This is one of the earliest recognition and parsing algorithm. And the only thing is that it only works with CNF. Can anybody tell what CNF stands for?
Chomsky normal form.
Very good. Chomsky was a scientist who gave us this Venn diagram, regular grammar, then the context-free grammar, then context-sensitive grammar, right? Then recursive, right? grammar hierarchy. I hope all of you have seen this in the video lecture series. Have you? Or if you are from the computer science background, these concepts are thoroughly covered in the subject theory of computation. So
Yes.
moving ahead, what are the CNF rules? We saw the rules for CFG that were super easy. What were the rules? Alpha goes to beta, where alpha can be some non-terminal and beta can be non-terminal. We can also represent with the help of V, and beta can be any combination of terminals and non-terminals. But in the case of CNF, how do the things change? Let us see. This can be one theoretical question also. So in the CNF, you will have a starting symbol, and then you will also have the LHS and the RHS. Now, what in the LHS and RHS? Because in general, this is what we have in any grammar. So LHS will have a non-terminal. LHS will have a non-terminal. This is also in any normal grammar form, that in LHS you can only have a non-terminal. If in some LHS you have S and then it gives you NP, then this is not a valid rule. Why? Because it opposes this property that LHS will only have a non-terminal. Okay?
Start symbol is never considered a non-terminal.
Sorry?
Start symbol is never considered as a non-terminal.
Start symbol is always considered as a non-terminal only. It is never considered as a terminal.
Yeah, but the notation, if it is other than S also, it can be a sentence
Then
startup,
it should
right?
be specified in the question. Say if I want to use A as the start symbol, right? How
Yeah.
will I know? It should be defined in the question. By default, the notation for the start symbol we take as S. Okay? Okay.
Okay, and S cannot be in the RHS.
No, it cannot be in the RHS. If it is a start symbol, it should not be in the RHS.
Okay.
Or maybe it depends on grammar to grammar also in some scenarios. Okay? Say if
Yeah,
the
sure.
grammar is A goes to B S, and then S helps you to derive B A or A, then you have it. But here, whether A or S, what it stands for is not clear. So as of now, in the context of NLP, you assume that S stands for the start symbol until and unless specified, right? And it does not appear in the RHS. As of now, you can assume if there is anything you encounter, let me know. We can discuss on that. Okay.
Sure, thanks.
So coming to LHS will have a non-terminal, and then the most important part is what RHS can contain. So RHS can have a single terminal. That is also okay. That is in the case of CFG also. Two non-terminal it can have. This is very important point. In the case of CNF, you can have two non-terminals in the RHS, but this is not the case with CFG. Okay. So, oh, sorry, pardon. CFG, you can have any combination of non-terminals in the RHS. Say, S helps you to derive A, B, C. But in the Chomsky normal form, you can have only two non-terminals, either A, B or B, C, or some combination. Okay? You cannot have more than two non-terminals. See here, beta says in the RHS, you can have any combination of non-terminals and terminals. And star here stands for one or more than one occurrence of it. But in the Chomsky normal form, we are restricting you. We are saying you can have only two non-terminals in the RHS. Okay? But you cannot have any combination of non-terminal and terminal. That is not allowed in the Chomsky normal form. Combination of non-terminal and terminal is not allowed. You need to remember what it can contain and also what it cannot contain. And it cannot have a single non-terminal. It cannot have a single non-terminal. So let us have a look at these rules. So as I discussed earlier, this is a little important concept, so please pay attention, all of you. So I said here, RHS can contain what? Single terminal, only two non-terminals. It cannot have a combination of non-terminal and a terminal. And it should also not have a single non-terminal. That is also not allowed. So corresponding to this, what we can say is single terminal, A goes to A. Is it allowed in CNF Chomsky normal form? Tell me.
Yes.
Yes.
This is allowed. Now A goes to B, C. B and C. Is it allowed? Only two non-terminals.
Yes.
NP goes to N, PP, prepositional phrase. Is it allowed? Two non-terminals.
Yes.
Allowed. Now this is allowed. NP goes to the and some non-terminal.
Not allowed.
Not allowed. Is this allowed? NP goes to the determiner noun.
No.
No.
Is this allowed? NP goes to determiner noun paraphrase, prepositional phrase. Three
No.
non-terminals.
No.
Understood? These kind of questions can also be asked.
But will there be a notation of using this POS tagging as two characters?
Yes, definitely you should know that PP stands for prepositional phrase. Okay?
With what is the delimiter? Only space is the distinction. Huh?
Yes. As of now, yes. Okay?
Okay.
PP stands for verb phrase. As I said, CFG is a phrase structure grammar, no? Remember we discussed what are the different names of CNF?
Yes, ma'am.
Now, to use CKY parser, you need to convert CFG to CNF. We discussed this point also. How will you do that? So let's say as we were discussing, we had one rule like this, the, and then we had some non-terminal. What you could do here is, now the question is how to convert to CNF. What you do? You introduce some dummy variable. Dummy non-terminal to original terminal. What I should write here? I can write There is a determiner D that helps me to derive the, right? And then this rule will be modified as NP. The will be replaced by what? B and NT. NT is non-terminal here, one word only. Understood? Understood?
Yes.
Now, can you do for this? Another invalid rule that we had was determiner, noun, and paraphrase. So, can you do for this? How will you convert? NP goes to determiner, space noun, space prepositional phrase. Sorry, it's not paraphrase, it's noun phrase. Can you do? Introduce some dummy variable and then solve it. Try, try once. Either you club these two using some dummy variable or you club these two. Okay? Just try and let me know when you are done. Please raise your hand. There were questions in the assignment when I had looked how many steps are needed to convert CFG to CNF, right? How many non-terminals are needed? How many steps are needed? These kind of questions can be asked.
Actually, about this epsilon or nullable terms also is part of this CNF, is it?
Yes.
And when do we say this grammar is valid? If there is a redundant, I mean, the same rule is repeated,
Mm-hmm.
you have to consider it's invalid, is it?
Oh, sorry, I didn't get your question.
Suppose A derives B
Mm-hmm.
and again A derives A.
A derives A. Yes. This is ambiguous grammar, no?
Now, A derives a terminal.
Let's say the.
Yeah.
Then what does B derive?
So given any grammar, it has to lead to a valid sentence, is it? Otherwise, it's invalid.
Yes. So as I discussed, as I discussed, there can be some challenges in the grammars, right? As we were discussing here, recursion. So as if we go by your example, A derives B, B derives A. It will be a cycle, right? A derives B, B derives A derives B. So I'm looping again and again, right? Recursion is there. It is calling again and again, right? A is calling B is calling A. So we can see A is calling itself, or we can say A is calling B is calling itself. So this recursion problem is there. So if these kind of problems are there, you could mark like what one of the challenges is, whether it is ambiguity or recursion or some substructures are being repeated. Valid or not
In
valid,
the,
I am not clear with what do you mean by a valid grammar.
in the same example, whatever you written,
Mm-hmm.
a non-terminal A deriving a non-terminal B,
Mm-hmm.
and the non-terminal B is deriving a terminal lower B.
Hmm. A is
So in
deriving
this,
B is deriving A, and no, not it is deriving this you are saying.
yes,
So let us do it. What it is doing, it is helping me. A derives B derives A. So at any point of time, if you see this grammar, with this grammar, I will be able to get at least one B, right?
yes,
A derives
yes,
B and B derives B. If we stop here, it is okay, right? But if A derives B derives B, this is one combination. A derives B. Also, if you would write here A goes to AB, then it will be better, because then I can have B plus. This will be the strings that this grammar will produce. Either just one B or more than one B, right?
yes.
So you have to determine like always some rules will be given, and what they are helping me to derive, that will also be given, right?
Yeah,
Whether
this
it is
grammar
terminal.
is yielding some of the other thing, but we can say this grammar is valid.
Yes, this is valid because it is helping me to derive a combination of strings that contains at least one occurrence of the character B. So you just try to derive some strings which that grammar is producing, and if you're not able to get any meaningful combination, then you see whether it is valid or not. And this set of rules is always there to help you determine whether the grammar is valid or not. I wrote na CFG rules.
Yeah.
So that will help you to determine whether the grammar is a valid CFG or not, always. And even if you have a doubt there, then you go for this alternative approach. Try to derive some strings from it. I hope that answers your question.
Yeah, very much. Thank you.
Okay, thank you. So I hope all of you have done this part. Let us try. Let us try. So say if I club these two, I say determiner and noun. This can be some letter A. Some terminal, a non-terminal A helps me determiner and noun. So what I can write it as, noun phrase give me A, and prepositional phrase. This can be one combination, like this is first way to solve. Second way to solve it would be A can give you noun and a prepositional phrase. But remember, you could only club the consecutives. You could not club determiner and the prepositional phrase and say, ma'am, this is this. Okay, let me first do this one, then I'll come to that point. A is helping me to derive noun and the prepositional phrase. So this part is done, right? So what we are left with, determiner and A, and this is NP. Clear? Or so that you do not get confused, let me say this is A dash. So what you could not do is say that A double dash gives determiner and the prepositional phrase. So I will write like this. NP gives me. It will not make any sense anyways, right? So this is not a valid choice. This is a valid choice. Understood? I hope you have done this way. There are two answers to it. Because in the Chomsky normal form, we can have only how many non-terminals? Only two. Clear? Is it clear to all present in the class?
Yes, ma'am. But ma'am,
Mhm.
in that example, we can also replace noun and preposition phrase because these two are non-terminal and we want two non-terminal.
That's what I did in the second case, right?
Yeah.
A dash gives me noun and the prepositional phrase. So now you replace this part, determiner and A dash. That's what I did, right? I showed you both the possibilities.
This is also in CNF form, na? So we can
Yes,
do also.
yes, that's what I said. There are two possible answers to this. First way and the second way, right? Any
But
doubt?
you said the most probable choice is
I didn't say like that, that the
first.
most probable choice is either the first or the second. I'm just talking about the possibilities here. Okay?
So
Both are
you
equally
said for
valid
the
answers.
determine and proposition. You said for that.
Yeah, I said that you cannot club the determiner and the prepositional phrase because they are not consecutive. You could only
Oh,
club the terms that are consecutive, one after the
okay,
other.
okay, ma'am. Okay.
Understood?
I
Never talk
understood.
about
Okay.
the probabilities of it.
So here we can consider as two new non-terminals derived.
No, how there are two? I'm just talking about the possibility. First way can be you take A that gives you determiner and the noun. So this becomes now A, and what you're left with, prepositional phrase. This is one answer. Another way can be somebody could say, ma'am, I want to club these two, the last two non-terminals. So this can be one answer. So how many non-terminals are needed to convert this to a prepositional phrase, to a CNF form is just one, right? Either A or A dash.
No, but all possible combination production rules will be preparing, na, given a gram CFG
I didn't get.
for
Could you
CNF.
please repeat?
For CNF, we prepare all possible production rules from the given CFG.
The questions are usually asked like how many variables or how many non-terminals are needed, or if it is like
Yeah,
multiple
they
select, then you
don't.
can tick all of them.
Okay, because they are not given the sentence. We don't know which of the rule can lead to a valid sentence.
Yes, yes. Then you can try with any of these two combinations, right?
No, but considering how many non-terminals are added by
And at any
converting
point
the
of time,
CFG
you
to
can see
CNF.
only one non-terminal is being added, whether it's the first possibility or the second possibility, right?
Okay, but a number of possible production rules we can consider 3 year, right?
Three, why three? Only two are there, na?
Now with the different concatenation, it is a different combination, right? A dash is having a different combination, and A is having a different combination.
So at any point of time, there are only two possibilities to this. How three you are saying?
Now the given base is NP equal to determinant and noun PP.
Huh?
That is the given out of which we can derive NP as A and PP, A and PP,
Uh-huh.
and the other one is NP as D and A dash.
Huh?
So overall, three production rules we have finally.
Yes, yes, yes. Overall, yes. Overall, you cannot say because you want to convert this CFG to CNF. At any point of time, you will have either this or this or this. Yeah, it depends on the structure of your sentence, how you want to, right?
Now, because they're not giving a sentence in the
Yes,
question,
yes.
they're
And
giving
just
given us
let
here.
us restrict to the question that is being asked here at this point of time, right?
Okay.
Because we are not talking about some grammar here, okay? Or some sentence. If it comes, we can talk about it.
Okay.
Immediately the question follows. Maybe this helps you to understand.
Ma'am, if we consider terminal, only one terminal is allowed, right? In the
Yes, yes,
RHS?
yes. Single terminal is allowed.
Oh.
I need to check for this. Just let me know if there is any, you find something that does not follow it. I'm sure that single non-terminal is not allowed. Just let me know. Okay? If you find that this is like, let me know in the next lecture. Okay?
Yeah, it will be good if you can include that epsilon one, nullable one.
Okay. Sure. Let me know. I can add it and update the lecture notes before sending. Okay?
Yeah.
Okay. Now let us solve this one. This I really wanted you to solve. Okay. So, given the CNF rules on the RLHS, I am writing on the LHS of my screen. So, S gives you NP VP. NP gives you some determiner and a noun. VP gives you VNP. V is includes. Determiner is the, also a. N is meal and is flight. The question goes like, the flight includes a meal. Let me tell you here, these are the syntactic rules based on the syntax. These are the lexical rules. Chalo, let us try to see how this is done. So should I solve or would you try to see how the tree comes like out of this? All of you just give it a try for a minute, then I'll discuss an alternative approach. Okay? Just try with the normal, like how we draw the parse tree using the top-down parsing approach, starting from the start symbol and coming to the leaf nodes. What set of rules should be chosen? Okay, it's quite straightforward, but just try once. Okay, all of you, please try. So let us see how we can do it. Yeah. So how does it go is, the is a determiner, flight is being used as a noun here, verb, determiner, and you can also see from here also how they're being used. Production rules are given, they're pretty straightforward. So we start with the symbol S. S gives you NPVP. First of all, what I want is a determiner, so I go ahead with this production rule, determiner and a noun, right? And the then using the noun, whether I should use here, okay, only determiner and the noun is given, not NP. Okay, so using the noun I can get flight. Now from VP I should go V and NP. From verb I can get includes, and from the noun phrase what I can get is a determiner and a noun. Determiner is a, and the flight includes a me. Clear to all? This is pretty straightforward.
ma'am.
Okay, now let us see an alternative approach which I wanted to discuss with you. Please pay attention. This is really important when we will do the probabilistic part. Same question will solve with the probabilistic grammar also. This will be really helpful if you understand it carefully. So see, what you do, this is an alternative approach to solve. Just write the numbers, how the words are appearing. Starting may you just write 0. In the starting write 0. 1. Every space you number it. 3, 4 and 5. Okay, clear? First of all, you draw a matrix. Matrix size should be how many words you have, and it should be a square matrix, 5 cross 5. What you do is, now you draw the matrix. And from here you start the numbering like 1, 2, 3, 4, 5. So in the columns you start from 0, but in the this this side you start from 1 only. Okay, we'll see, it will be very interesting, and this really helps a lot when we do the probabilistic grammar part. So at any point it doesn't make sense, let me know and ask your doubts. So let us solve. What color to choose? Okay, let us choose red. Okay, so now just write the word that appears in between, what places it appears. So the cell 01, you can fill with the word the, and better than the, you fill it with the part of the speech. Okay, so what I should write in the 01 itself is the, that stands for the determiner. Clear? Is it clear?
Yes, ma'am.
Now in 1 and 2
Yes, ma'am.
position, yes, correct. Thank you. In 1 and 2 position, flight appears. From this, production rules determine what flight is. It acts as a noun right now. Okay? Now, what one important point you have to keep on saying at every point is as soon as you have two, because in the Chomsky normal form you are considerate of two non-terminals in the RHS. LHS can have only one non-terminal, right?
Terminal.
This is the rule that we need to follow in the CNF grammar. So what we do is, I have seen D, I have seen N. Now, am I able to see this in any of the RHS? In any of the rules in the RHS? Yes. Let us check with the first, NPVP. No. Second rule, it does
NP. Second
satisfy,
rule.
right? So what you do, you write NP here, determiner and the noun, and ensure that it always form this right angle side thing, this triangle side thing, right angle triangle. Okay? Clear? We will see how it is helping us to derive the coming to the start symbol in the bottom up approach. Okay? Shall we continue till this point? Is it clear?
Yes, ma'am.
ठीक है. Now let us move to 2 and 3. 2 and 3, what we have? 2 and 3 we have includes, which acts as a verb. So put it verb. Now you see, noun phrase or the verb, or the noun and the verb, are they appearing anywhere? Noun phrase, so it should appear in this combination. Noun phrase and a verb,
No.
or a
No
noun and
combination.
a verb. Are we getting it anywhere? Let us check. Noun phrase and a verb, noun phrase, verb. Nowhere. Noun and verb, we are not getting. So we will not write anything here, not anything here. Okay. Let us move to the next step. Now, in the cell 3, 4, because you are having only this diagonal kind of a thing, there only you will write. What you will write? A. A is a determiner, right? Now again check for the right angle triangle thing. V and D, we are having anywhere in the RHS of any production rule? No. But do we have? So we are not having V and D. But do we have N and D? Can you check? N and D, are we having? We are not having. N and V we are not having. N and D we are not having, right? Let us move ahead. We have checked. NP and D also we are not having. Check all the possibilities. ठीक है? Not having. Okay, let us move to the next cell. 4 and 5. What is it? Meal. Meal stands for the noun. Now check determiner and the noun. We are having in this production rule. What is it?
NP.
Write it here in the immediate one. Now you check verb and the noun phrase. Are we having anything? Verb and the noun phrase. What we are having?
VP.
Verb and the noun phrase. What we are having is noun is here. NP should come here, and because it is in immediate surrounding of this, so you write VP here itself. Now you check for N and VP. N and VP,
Sure.
because this will form. So N and VP, do we have?
Yes. Start.
N and VP. Yes. No, that is NP and VP. No, this is N. I'm talking about N. N and VP we are not having. But if we check for NP and VP, what we have is the
Yes.
S. Understood?
Ma'am, so here BP and B are different thing and NPN are different thing. I
Sorry.
think so. In the given grammar, BP and B are the different thing.
VP and V are
Both.
different things. VP is helping you to derive a phrase here, right? V followed by NP. But verb is a single verb here. As I said, There is nothing strict, just refer to the production rules. Okay?
But ma'am, in the previous example where we have written N, then we are able to replace with NP, I think so.
Where? This example?
Not this example that we have solved earlier.
So there the grammar is like that, no? And if nothing was specified, so I took it on my own. But here everything has been clearly specified in the production rules. Okay? The production rules are clearly stating that NP here is standing for the phrase because it is helping me to derive two of them. But N is just a noun. And what noun it is deriving, that is also given. So if it is given, strictly refer to it. Refer to always the production rules and the grammar at any point of time. It can be different in one question and different in another question. Okay? Clear?
Can you tell me again how we take the all possibilities?
Where?
Like where we have written nothing. 1 3, I think.
Sorry, I didn't understand.
At the cell of 1 3
At the cell
in
of 1,
place.
3. So you want me to solve it again, is it?
Yeah, ma'am.
One small question finally here. If we are not arriving at the start symbol at the finally, then it's wrong with the grammar, or we have done something
You have
wrong.
done something wrong. There is nothing wrong with the production rules that are given to you. You need to reiterate, okay? Okay?
Yeah.
If the question is set wrongly, that is a rare chance, then it can be, but mostly your production set rule is wrong and you need to check your solution again. Okay? So I'll solve it quickly because I also wanted to cover the probabilistic CFG. So 1 and 3 cell you wanted me to solve. Now I'll solve till there only. Okay? That will be fine, right?
Okay, ma'am. I just want to know the possibilities
What possibility?
how
Okay,
we
let
are
us see.
taking.
Okay,
I
okay.
mean,
Just see. Just follow. So 0 and 1 I will write determiner. Nothing is there. So I'll go to cell 1, 2. 1, 2 is again a noun. So now determiner and noun I will see. What it is giving me is a noun phrase. Right? And I said follow this right angle triangle thing. It helps us to map the things easily. Now move to the cell 2, 3. Okay? Because only in the diagonal we will be having the elements that we are putting from here. So in the 2 3 you will put a verb, right? Now you wanted me to do this, right? So we see here n and v have no such combination, right? And nowhere it is saying that np is n. This rule is not there. So n and v I cannot have anything in this cell, right? What I will do, I will again then move to this possibility, NP and V. Is there any such possibility? No. So I will leave this also empty. Did you understand now?
so ma'am, we will check here two possibilities, NB and NPB.
Yeah, definitely you will check. This right angle scenario will satisfy here also, right? You just need to check two non-terminals are there in the RHS. If they are helping me to come to some symbol that is there on the LHS, then definitely I'll take it and move forward. This is not the case. N and V is in none of the production rules as a combination. This should appear on the left, this should appear on the right. NP, VP, DN, DN. It's not the case N and D and you will derive something. D should definitely be on the left of N. Then only you can get this phrase NP. Okay? That's why I'm telling you right angle triangle thing. Because this falls to the left and this to the bottom of it. Understood? I hope your doubt is cleared. Or is it not?
So the point we are ready to take like 1 3. So this is the left hand side, and NB and NP are the right hand side.
Yes, NP will be the
These are
LHS if something comes here, and this will be the RHS, है ना?
okay, ma'am.
ठीक है? Is it clear now? Shall we move ahead?
Yeah, sure, ma'am.
Okay, V was here, then determiner D was there, then again N, and then we had here VP, and VP and V no such combination was there, N and VP no such combination, but NP and VP we had combination S. Now say in your grammar, in the probabilistic CFG, what you will be given is some possible probabilities you will be given. What can those probabilities will be? Like there will be a probability that is associated with every rule. Let me move to the next slide and I will again explain this probabilistic CKY. CKY. Same example. S goes to NP, VP. NP goes to determiner noun. VP goes to VNP. Please be there until this question is over, even if the time gets over, because this is a really important question and I have seen in the assignment you are having a paragraph based questions on this. Once you are clear with this approach, then it will be easy and gives you meal or flight. So here this symbol stands for or. Don't confuse yourself. The determiner can be like same thing, determiner the, determiner a. Same thing I have written in this fashion, meal flight. So what you have in the probabilistic CYK is, and I want to clarify that this is V space NP. Do not get confused again. So now let us see what in the probabilistic CKY you have. You have the probability that is associated with every production rule. So say in the question it is given like this. Zero point zero 0.05. Now I need to rewrite it. Why? Because these will be two different production rules. This will not begin. Now you understood why I erased it. As I said, you didn't point me out. It RHS can have only a single terminal. Okay, so I should not have written in this format that determiner is the and a. Okay, this is wrong. I should write determiner is the, determiner is a. Okay, noun is flight, noun is meal. Clear now how we are referring to the grammar rules at every point?
Notation wise, if the probability value is same, also you cannot represent with or
No,
symbol.
no, never. Because it will go against the rules of the CKY parser, right? So you here only
But
you see
ma'am, in
determiner the probability 0.4, determiner a probability 0.4. Two different rules, same probability of the rule. Yes, please. Somebody was asking a question.
but ma'am, in the assignment, they have given us in the slash form like cricket and football,
Okay, then
music
what
and
you do,
painting.
you assume it. You decompose that rule like this for your clearer understanding. I also decompose, na? In front of you only.
Ma'am, there is also given so if you can see the assignment, you can clear that.
Shall I solve the question first or see the assignment?
Okay, ma'am.
We'll discuss this after the question is done. So I am saying it can be given in the question. Say in the question it is given like determiner is the and probability is 0.4. This can be given in the question. For your understanding and for you to keep everything clear, you decompose it like this. This is what I am saying. I'm not saying in the question it is giving wrong. Okay? You decompose it like this for yourself. Okay? I hope that resolves your doubt.
No, ma'am, there were also given just like here is given determine implies the slash a with probability zero point 0.4. And in the assignment also given the another uh, rule, determinant tends to a slash the, means two times and with the probability with the different probabilities like 0.3.
I think we'll take up that question later. Let me just solve this first. Okay? We'll take it towards then. So as I know, I can, the question is the flight includes a meal and how to draw the metrics and everything is clear. We discussed in the previous slide 0, 1, 2, 3, 4. And here we will write like 1, 2, 3, 4, 5. How to draw that is clear to all of us. So what I'm going to do is the stand for determiner, flight is noun, includes is a verb, determiner, and meal is a noun. So I will write first of all here determiner, noun, verb, determiner, noun. And now I will see what combinations it leads to. So determiner and noun gives me NP. NP this gave nothing, this gave nothing, and D and N gave me what? NP. Then V and NP gave me what? VP. And NP and VP gave me what? Start symbol. So now you want to derive the probability for this. So how will you derive the probability for this production that we are getting is, you see, NP is composed of D and N. What is the probability associated with the rule NP? 0.3 with the determiner, that is the. What is the probability? 0.4. With noun, what is the noun here? Flight. So you go to the production rule where noun is flight and it is 0.01. So you take the multiplication of the 3. So for here, what you will have is 0.3 into 0.4 into 0.01. Clear? So what does it come out to be? 0.12. How many zeros? 1, 2, 3, 4. 2 zeros. Clear? For this we have this probability. Clear? Is it clear to all?
This procedure, first we have to go with the matrix and then the tree.
Yes.
Since we are multiplying, what if I directly go with the tree and
Up to you. I prefer it this way. This is one alternative to solve. You can directly go with that as well. Okay.
okay.
So now here, now you want to determine for this. See, the rules is still the same, but here things change. How? NP, DN. Why? Because how the things will change here. Determiner is here a. So you take the probability for this rule. Determiner a 0.4. Now noun here is meal. Now you take the probability for noun meal 0.02. It changed 0.4 and here earlier it was 0.01, here it changed 0.02. Noun phrase probability remains the same 0.3. So here what the multiplication comes out is 0.3 into 0.4 into 0.02. Okay? So whatever probability now comes out here, then your VP will be V and NP. Whatever probability that you get after multiplying is 12 into 2, 24. So this will be 24 and how many zeros? 2 zeros. Right? And V. What is V here? Is includes. So 0.05 into 0.024. What is the probability associated with VP? 0.20. This way you take the multiplication and do. Okay? Clear? Is it clear?
Yes, ma'am.
Huh. So I hope you can complete this matrix. And now let us come to your doubt in the assignment. Let me open the assignment and see. So other TAs must have covered those questions, I guess. Or was it not covered in the previous two tutorials?
Madam has covered.
Hmm?
Yes.
Sorry?
On Sunday. On Sunday they have covered.
They have covered already, right?
Sachin sir. Yes, Sachin sir.
Okay, let
No,
me
actually, there is a confusion in the solution.
Acha. Let us see. Let us see if I can be able to resolve what question? Dear, what question?
Question
Fifth
number
one, madam.
third, I think. I mean
Third.
fourth. This
Third and
one, this
fourth.
one. Fifth one.
This one.
Fifth one, madam.
Fifth one. Okay. What we are saying is, yeah, tell me what is your doubt.
Here, ma'am, NN given to cricket slash football probability 0.15.
Acha.
Same NN implies football slash cricket 0.10.
Okay.
What we take?
Okay. What is the sentence? W1, W2, W3, W4. This is a confusing scenario. Can I get back to you on this? I'll discuss it with sir or with the other TAs and let you know, okay?
Okay, ma'am. But, ma'am, okay.
Yeah, last session he told that whichever is the higher probability, you just consider and do it actually. So wherever cricket or football comes as a noun, noun nominal, then we can take it as 115 instead of 10.15.
That is just an assumption, or is it a standard practice to take the maximum of the two? Any
That's what
comments
he
on that?
mentioned actually. That's what he mentioned on that day. If there is multiple probabilities, you take the higher one.
Okay. So I think Vandana, that was your doubt.
Yes, ma'am.
Sure, sure. Listen, I'll get back to you on this maybe over the mail or in the next lecture. Okay.
And can you just glance on the question number 8 once?
Question number 8. Which of the following grammars are valid? CMF. So first one is not valid, right? Because it is having three non-terminals in the RHS, right?
Yeah,
A
only
goes to
doubt about
CD,
the
B goes
D.
to B, and B goes to epsilon. So this is also valid because epsilon we consider it as a terminal only, right? C goes to C, C goes to C, C goes to C. So on the LHS you can have a non-terminal and on the RHS you can have a single non-terminal. This is also valid. This is
No,
also
the
valid.
second one, how can we have two terminal definitions for the same non-terminal?
But these are two different production rules if you see. You are having
Yeah,
a single non-terminal, a single terminal at any point of time. So take it like this. See, in here even when we were discussing this question, we were having determiner can be the, determiner can be a, right? We are having two different non-terminals but at two different points. So what it means by a single non-terminal is, single terminal is determiner can be a, determiner can be the. Same rule you can rewrite as determiner can be a or the. But what it does not mean is determiner cannot be a and the at the same time. Understood?
okay.
So in your case, what you are having is B goes to B, B goes to epsilon, which I can rewrite as B goes to either B or epsilon. This is valid, right? If it were like that, B goes to B epsilon, then it wouldn't be valid. Or say it was B goes to B C or B goes to B E, then it would not be valid, right? Because you are having two terminals for a single production rule, two terminals at given point of time, right?
Mm, yeah,
Understood? I hope that clarifies your doubt.
yeah.
Okay. So, thank you all. That's all for today's session. There were some.
The last one in the same question, D is also valid one, is what I assume.
Which one? Yeah,
The
D is
C,
valid. I already said. All of them are valid except for the first one because you are having three non-terminals. But you
no,
can
this,
definitely convert it. This is a valid CFG. You can convert it into CNF by introducing the dummy variable concept I discussed today.
no, the C is also valid, is it?
C is
Redundant,
valid, right?
same rule,
I
but
think
it's
it is
redundant,
valid.
right?
Just that the rule is repeated.
Yeah.
But it does not, any of the production rules does not violate any of the rules of the CNF grammar.
No, it's we have to choose a single answer for this.
So you have to choose a single answer for this. So the most suitable answer is option D,
Okay.
right?
Yeah, that's what I assume.
Yes. Okay then. Thank you all for today for joining. I hope you got your doubts clarified and understood some concepts.
And this applying this concept through Python, we
That
have it
we have
since.
already run out of time. Maybe my notebook is ready. Maybe I'll take it up in the next session if you really want to have a look at it.
Yeah, is it only from this session, or we have it for all the syntax and POS tagging, everything? We
I
have a
have
Python
covered
libraries.
almost everything. Like in every session, I try to take it from the coding perspective as well, right?
Okay.
So I have already uploaded the Python notebooks for the previous sessions. If in the next session you want me to discuss the Python concepts for this week video, I'll definitely take it up.
Sure. Thank you.
Okay. Thank you all for joining.
Thank you, madam.
Thank you, madam.
Thank you, madam.
I'll get back to you on that doubt of
Thank you,
football,
ma'am.
cricket, and cricket football. Okay. Thank you.